There are many different configurations and technologies that are used to make dry bulk separations. This short video highlights the key factors that affect the performance of these technologies. The function of a screener or separator is quite simple. A flow of bulk material, generally containing a broad range of particle sizes, is introduced or fed to the unit. The output is two or more separated fractions. The separator utilizes precision screens to filter the material inside the unit. It is the technology utilized by the individual separator manufacturer that determines the effectiveness of the separation, thus the return on investment provided by the screener. The technologies utilized by the separator manufacturers can be broken down to three main mechanical characteristics, those being slope, motion, and blinding control, and a fourth relating to the experience of the manufacturer, screen selection. Each of these parameters has a profound effect on the output of the screener. The slope of the separator can range from level to almost 40 degrees from horizontal. On a low-angle screen, the aperture presented to the particle is nearly the exact aperture of the mesh chosen for the separation. For example, a 2 mm opening will appear very close to 2 mm to the particle, and the resulting separation will be very precise. On a high-angle screen, the aperture seen by the particles is reduced, thereby causing some particles that are close to the size of the actual mesh aperture to pass over the screen, which results in a loss of efficiency. A low-angle screen will provide more precise separations than a high-angle, which means less product loss in the screening process and a higher return on investment. The motion as seen in this clip of an Apex screener by Rotex is very effective for accurate separations. This gyratory reciprocating motion, as it is called, has three distinct actions. The first, where the incoming feed enters the machine, is a gyratory motion. The motion quickly spreads the particles across the full width of the screener and starts stratifying the flow and conveying it down the screen surface. The motion gradually changes to an elliptical pattern, which promotes conveying and enables the screener to utilize a very low screen angle. Finally, the motion becomes nearly linear, providing a sifting action to assist in the efficient removal of the maximum amount of near-size particles. Many screeners utilize a vibrating motion in order to convey material down the screen surface. A vibrating screener imparts a vertical force to move the material down the screen by throwing it forward. While the particles are in the air, they do not have a chance to find an opening, resulting in reduced screening efficiency. A gyratory or gyratory reciprocating motion is generally in the plane of the screen surface without a vertical component, so the particles are in direct contact with the screen surface for maximum exposure to the aperture. A separator with a gyratory reciprocating motion in the plane of the screen surface will be more efficient than one using a vibrating motion with a strong vertical action. The gyratory reciprocating motion naturally stratifies the smaller particles toward the screen surface. This creates a condition that enables the screener to deliver very precise near-size separations. All separators, regardless of their technology, are subject to clogging or blinding, the effect of which reduces the open area of the screen and therefore its performance. The more effective a separator's motion eliminates or controls the blinding, the longer it can operate without cleaning. Rotex screeners utilize a ball mesh cleaning system, as seen here, in order to control the tendency of materials to blind the screens. The long-stroke gyratory reciprocating motion drives the mesh cleaning balls into the underside of the screen, cleaning out the material. Shorter stroke gyratory and most all vibrating screens provide less force and are therefore less effective at mesh cleaning. A long stroke gyratory reciprocating motion will keep a screener operating longer than other mesh cleaning systems, minimizing unplanned downtime. Proper screen selection is critical to the performance of the separator. a gyratory reciprocating screener has a gentler motion than a vibrating unit, which enables the manufacturer to utilize screens with more open screen area for higher unit capacities. Screens that are selected for long life may not enable the capacity required for the application. It is important that the manufacturer has sufficient experience to select the right mesh for both your process and the chosen screen technology. With over 100 years of experience, Rotex, a leader in gyratory reciprocating screening, has the expertise to provide the optimum mesh for both high-quality product and high throughput to maximize the potential of your application. The Rotex Apex model shown here, the Rotex Screener, and the Megatex XD from Rotex Global all utilize the gyratory reciprocating motion to provide high-yielding, high-quality separations for a wide range of applications and process rates.